Planar tracking addresses many of the shortcomings of traditional 2D tracking. The goal of tracking is to automatically follow the movement of a series of markers in our video. In this manner, we can perform a variety of operations, such as replacing one portion of an image with another. For example, assume we want to change the photograph in this frame. Using 2D tracking, we would have to track, one by one, the 4 vertices of the frame. In this way, we get the movement and rotation data we need to insert a new image. The issue is that this technique frequently fails to work properly. For example, because the 4 corners are not easily identifiable or properly tracked over time. Planar tracking tracks an entire surface rather than individual markers. In practice, we define a surface to be tracked, and the software identifies a series of markers automatically. In essence, planar tracking is also based on the tracking of individual markers, which leads to 2D tracking. In this case, however, a large number of points are automatically tracked, all of which are part of the same planar surface. As a result, tracking the movement, rotation, and scale of a surface is much more effective. This works even when tracking individual points would fail. This is possible because planar tracking follows a set of markers that define a surface's texture. Once the surface has been identified and tracked, the tracking data can be linked to another image. We can easily replace our photograph this way. The surface we use to track movement does not necessarily have to be contained within the area to be traced. Planar tracking can define different planes due to parallax movements. If the tracking area includes a portion of the background, the software can determine which points belong to the same surface, based on the differences in movement between foreground and background points. As previously stated, planar tracking involves tracking a large number of points that belong to a single plane. This enables us to circumvent many of the limitations associated with 2D tracking. We've seen that in 2D tracking, such as corner pin, it's critical that the markers have certain properties, such as being associated with areas of high contrast, not changing shape or scale too much during tracking, and not leaving the scene. Planar tracking overcomes these limitations. In fact, if tracking a few markers fails, there are dozens more that can be used as a backup. Even if much of the object to be tracked leaves the frame, a portion of its surface still provides enough data for tracking.